Hello students, how are you all? I am Pratima Naik. Today we will discuss functions from Mathematics Class 12 CBSE syllabus. When we think of functions, we think it is a very difficult concept. Now let us see how we can make it easy. Now when we say function, we all think that it is a very difficult concept. But people think it in this way: function is a special type of relation. We observe functions when our relatives are present. So if we'll think that we'll start from relation and we'll go towards function, then we'll feel it is very easy, not that difficult how we think. A relation R from a non-empty set A to a non-empty set B is a subset of Cartesian product of A and B. The subset is derived by describing a relationship between the first element and the second element of order pairs in Cartesian product of A and B. The second element is called image of the first element, and we write R is equal to all set of order pairs x, y such that x belongs to A and y belongs to set B and x is related to y. We write the condition. Functions, let us see what is the relation between function and relation. A relation from a set A to set B is said to be a function if every element of a set A has one and only one image in set B. If f is a function from A to B and order pair A, B belongs to f, then f of A is equal to B, where B is called the image of A under f and A is called pre-image of B under f. The function f from A to B is denoted by f A maps B. Now let us see which relations are functions. So R is equal to 2, 1, 3, 1, 4, 2. R is equal to 2, 2, 2, 4, 3, 3, 4, 4. R is equal to 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7. Let us see which relation is a function. Now in the first 2, 3, 4 are the elements of domain of R having their unique images in the relation. So this relation is a function. For second case, if you will see that two element has two different images 2 and 4 in this relation. So relation is not a function. Now for third case, again every element has one and only one image. So this relation is a function. Or in a layman language you can say, if x is repeated, then it will not be a function. So let us see what is function. A function f from a set A to a set B is a specific type of relation in which every element x of set A has one and only one image y in set B. We write a function is defined from A to B where f of x is equal to y. Set A is the domain and set B is the codomain of the function. The range of the function is the set of images. A real function has the set of real numbers or one of its subsets both as its domain and as its range. We classify the functions as one or injective function, and second one is onto or surjective functions. Now let us see one injective functions. A function f defined from x to y is defined to be 1 or injective if the images of distinct elements of x under f are distinct, or if x1 and x2 are elements of set X and f of x1 is equal to f of x2 implies that x1 is equal to x2, then this is called 1 functions. Now please observe the ray diagram. You can see that here one element of x is mapping to one element of y. x2 is mapping to y2 and x3 is mapping to y3. So this is 1 function. Now second is not 1. When a function f is defined from x to y is not 1, it is many one function. Please observe the ray diagram. You will see that x1, x2, both the elements have the same image y1 in y. So this is many one function. Many has image 1. Next is onto or surjective functions. A functions f defined from x to y is said to be onto or surjective if every element of y is the image of some element of x under f, or for every y belongs to set y, there exists an element x belongs to x such that f of x is equal to y. Or in a simple language, we can see that every element of y should have a pre-image in x, or no element of y should be left which has no pre-image in x. That is onto function. When a function is not onto, it is into function. A function f defined from x to y is said to be into if it is not onto. You can see the diagram. Here y4 has no pre-image in x, so it is into function. Now these are the different functions ray diagram. You can see the figure. For first figure, it is 1 on 2. That means 1 is mapping with 1 and no element is left in set y. So this is 1 on 2. Now second, 1 is mapping with 1 but one element is left in y which has no pre-image. So this is 1 in 2. Now coming to third. Here you will see that x1 and x2, they have image y1, same image in y. So it is many one and it is onto because no element of y is left which has no pre-image in x. So it is many one on 2. Now coming to last one, it is 2 have the same image, and so it is many one, and if you see that y has an element left which has no pre-image in x, so it is many one in 2. So function can be written as 1 on 2, 1 in 2, many one on 2, and make 1 in 2. How to prove that a function is 1, 1? So as we have understood, this is the condition. If f of x1 is equal to f of x2, this implies that x1 is equal to x2. Then the function is 1, 1. That means if two y's are equal to each other, then their related pre-image are also equal to each other. Or if two images are not equal to each other, then their pre-images are not equal to each other. Example. So that the function f defined from n to n natural number given by f of x is equal to twice x is 1, 1. So while writing the answer, we'll proceed in the following way. We'll write that let f of x1 is equal to f of x2. Then in place of x, we'll write x1 and x2. So twice x1 is equal to twice x2. This implies that x1 is equal to x2. So the function is 1, 1. How to prove that a function is onto? How to write it? A function f defined from x to y for every y belongs to y. If there exists an element x belongs to x such that f of x is equal to y, that function is onto. Let us take an example. So that the function f n to n is given by fx equal to twice x is not onto. I have taken the same question. There it was 1, 1. Here we'll prove that it is not onto. F is not onto as 1 belongs to n, there does not exist any x in first set or the domain such that f of x is equal to twice x is equal to 1. That means in domain there is no x in natural number, so that twice x is 1. So 1 has no pre-image. So this function is not onto. If we'll see for your understanding this order pairs 1, 2, 2, 4, 3, 6, you will see that the range of this function 2, 4, 6, it is not the whole natural number, it is the subset of natural number. So this is one way of knowing that which function is onto, which function is into. If range is exactly equal to the same set, then it is onto function. If range is subset of second set, then it is into function. So that the function f defined from R to R, defined as f of x equal to x square, is neither 1, 1 nor onto. So first we will go for 1, 1. Let f of x1 is equal to f of x2. This implies that square of x1 is equal to square of x2. This implies that x1 is equal to plus x2 as well as minus x2. So when we are getting different values, f is not 1, 1, because for one y there are two pre-images. If you see this roster form of the function, 2 is pre-image of 4, minus 2 is also pre-image of 4. So it is many one function. Now for onto, f of x is equal to x square, this implies that y is equal to x square, or x square is equal to y, or x is equal to square root of y. So square root of y cannot be defined for all y belongs to real number. For example, -2 cannot be square of any real number, or -2 has no preimage in domain. So the function is not onto. So fx is equal to x square is neither 1 nor onto. Now can you think of if this function will be defined from natural number to natural number? Is it 1 Is it onto? So please think of it. Next question. Show that the function f is defined from real number to real number, defined as f of x is twice x plus 3 is 1 as well as onto. Now we'll go for 1. In the same way we'll proceed. Let fx1 is equal to f of x2 implies that twice x1 plus 3 is equal to twice x2 plus 3. This implies that x1 is equal to x2. 3 cancel, 2 cancel. So f is 1. Next we'll go for onto. So fx is equal to 2x plus 3 implies that y is equal to 2x plus 3 implies that 2x is equal to y minus 3. So x will be y minus 3 by 2. Now you have to think of for which x y cannot be defined. So we'll put y minus 3 by 2 in place of x, and if we get y after the simplification, then it is onto function. So twice y minus 3 by 2 plus 3 is equal to 2 cancelled, y minus 3 plus 3 it is y. So it proves that fx is equal to onto. So fx plus is equal to 2x plus 3, both 1 and onto. In next video, we'll learn about composition of functions and invertible function, inverse of a function, how to write the answers in CBSE board examination, because this is not the end of the function. Wish you good days.